What up, Sci Fam? It's too nice today, so I'll come in to you from the outdoors. You might hear some school ground chatter happening, but nonetheless, let's talk about some science. So we're going to look at types of chemical reactions. So as you can see, there are 4 major types of chemical reactions that we are going to identify. So you're going to want to fit those 4 things into your science notebook page there near the top, and then we need to also define endothermic and exothermic reactions. So leave yourself some space. Now, let's get started with types of chemical reactions. So whenever we look at a chemical reaction, one thing that's really important is that there's always going to be an arrow to show that there's a transition of the molecules you start with. They're going to regroup and create new types of things. And so the things that mix together, we always call those the reactants. So this is kind of just a review, but go ahead and record this down, that you always start with the reactants. And those reactants react with each other, the chemical bonds break, and then the molecules reform into new, unique molecules. And we call those products. So it's kind of like when you go to the store, you buy some products. Those products didn't just grow from a tree necessarily, not all of them, the things in the produce aisle did, but products are usually put together in a combination. So, you know, when you go get that little Tykes Jeep or something, the wheels were put on, the chassis was put on, the headlights were put on. You get products that are a new combination of all the little parts. So anyway, a chemical reaction starts with the reactants. It then goes through that reaction, which is why we call it reactants, and it creates products. All right, so when that happens, the first type of thing that can happen is you can start with 2 things. We're gonna have a circle that we'll put an A, we'll call that element A, and a square that's gonna be element B. And what can happen sometimes is that the circle and the square will actually join and share a bond with each other, and it'll become its own molecule. So this one that has a circle and the square bonded together, it's different than when the circle was by itself or when the square was by itself. So since these 2 combine together, we call this a combination reaction. All right, so our first type of chemical reaction is a combination reaction. Let's write reaction. Okay, well, let's say that we start with that type of molecule that has the circle and the square. We'll call that, again, A and B, and it's got a bond that's causing the A and the B to be joined together. That's why there's a line between the circle and the square. And in another different type of reaction, we can actually have the circle separate from the square. So now they're by themselves, and so they have their own properties because they're no longer joined together. This one is the opposite of combination reaction. This one we call a decomposition. It's like the opposite of a composition, putting things together. It's pulling them apart, so we call that decomposition reaction. All right, let's keep moving along here. Number 3. This one, let's say we start with a circle here, and this one has element G in it. These letters are just fake, so I can use them as examples. So let's say we have element G in the circle, and then we have that element that we were already, or that molecule we were talking about that has A bonded with B. And we can have something that we call a single displacement. So we're gonna knock the A out of there, and the G is gonna come in and take its place, or it could. So let's see what that would look like. So we'd have the G comes in and it bonds with the B, which means that we end up with the A by itself. Another option is something that could have happened. You could also, another example here would be if you had G and A with the B, you could end up with the G bonding with the A. And let's make sure we connect that bond. And then we end up with the B being left out there. So both of those are examples, because we're only replacing in that molecule, the AB molecule, we're only replacing one of the elements, and so we call this a single displacement. Okay, well, if we start with 2 molecules that are in our reactants here, let's say that we have G bonded to Z and the other one is going to be A bonded to B. Well, we can do something even beyond a single displacement, and this one's called a double displacement. So you can probably envision what's going to happen if you're seeing the pattern here. So the GZ bond is going to break, and so we're going to end up with, let's say we have G here, and we'll have Z over here. Oops, that needs to be a square. And instead of them being bonded to each other, they're each going to get something new to bond with. So now G is going to bond maybe with B, and Z bonds with A. Okay, so since two things got displaced here, we call this one a double displacement. And this is just a start. These are 4 types of reactions, but there are a few more types of reactions. But for our intro to chemistry and intro to chemical reactions, this is a good start. So you can start to see kind of how things behave when they go through a chemical reaction. Now, when we do this, a lot of times we're breaking bonds and sometimes we're making new bonds. Oftentimes, like in the decomposition, we're breaking a bond. In the combination, we're making a bond. In the single displacement, we break a bond and then we reform a new bond. In the double displacement, we break 2 bonds and we reform 2 new bonds. Well, all of that breaking and making bonds, that means that we need some energy to do it. It's not so easy. They don't just break on their own. You have to apply energy, or sometimes when a bond breaks, it actually releases energy. So something we need to add here is that all chemical changes involve a transfer of energy. So let's look at this first example. In the first type of thing that can happen, if energy is transferred, into the molecule, it's going to help build a bond. So in this case, energy is stored. It's stored because it pulls in energy. It needs energy in order to come together. So energy is stored in the bonded molecule, which it has to get that energy from somewhere. So it is absorbed from the environment. So if energy is taken from the environment, put into the molecule, then the environment gets cooler. So therefore the temperature decreases, or it feels like it would if you were to touch it, because as you touch it, it would pull energy from your hand, the heat from your hand. And when heat is pulled from our body, we feel cold because we don't get the heat. We're giving the heat. And so this is called an endothermic reaction, or something that is endothermic. And so you can kind of break this word apart and see that it's got endo, which means into, and then thermic, which means heat or thermal energy. Okay, so an endothermic reaction means that heat or thermal energy goes into the molecule, so therefore the temperature decreases and it feels, or it appears, cold. The opposite of that is that energy is actually released. So when those bonds break, it actually gives off energy into the environment. And this is like common when you think about like an explosion. That releases a lot of energy, but not all of them actually release that much energy. So some just release energy. That energy is released by the bonded molecules. And energy is released by the bonded molecules into the environment. And since energy is released into the environment, more energy enters the environment, so the temperature increases. So therefore, it's going to feel hot or warmer. In this one, since energy is released and exiting the molecule, we call this an exothermic reaction, or something that's exothermic. So exo means outside or out of. Thermic is that thermal energy. So the thermal energy goes out of the molecule. So there you have it. Reactions are either going to be endothermic or exothermic. Some of them are more subtle than others, but as we go through our science experiments, you're going to notice we have some endothermic and we have some exothermic reactions. So use those senses, use your observation skills, be a great scientist, and make some observations, my homies. Adios, amigos.